This is what a solar flare looks like. Wow. But what consequences can we experience on Earth? After all, light and warmth reach us wonderfully. So does the power of explosions? I'll tell you what happens to the sun, how it affects our daily lives, from illnesses to psychological states and world wars. And in the end, you'll find out when the sun might cease to exist, according to NASA's calculations. Watch until the end. And first, let's talk about the strange spots on the sun. Where do they come from? When studying the sun, small dark spots are discovered on its surface, varying in size and location. These peculiar spots are often found in areas around the equator and formed due to the interaction of solar plasma with magnetic fields. These spots have lower temperatures compared to their surroundings, reaching about 6,370 degrees Fahrenheit, which is 3,131 degrees Fahrenheit cooler than other parts of the sun. Despite this, a single spot can shine 10 times bigger than the full moon in the night sky. These spots may seem small against the backdrop of the massive sun with a diameter of 864 million miles, occupying less than 4% of its visible surface and comparable in size to Neptune. But why do they appear and disappear? Their lifespan usually doesn't exceed a few weeks. Solar activity changes every 11 years and reached its peak in 2013, after starting the cycle in 2008. In November 2014, the largest sunspot comparable in size to Jupiter was recorded despite the overall low solar activity. Currently, the sun is entering its active phase again, so 2024 is predicted to have a high number of solar flares and magnetic storms. Hold on, but what is all this if we speak in plain language? Solar flares are just temperature fluctuations. Strong magnetic fields in sunspot formation areas can cause flares accompanied by a massive release of energy, surpassing the power of millions of hydrogen bombs. During such flares, the temperature of the sun's corona, its outer layer of the atmosphere, can reach several million Kelvin, and in some cases, the temperature of the gas in the corona increases to 10 to 20 million Kelvin, sometimes even up to 100 million. According to NASA, the energy released during one solar flare is comparable to the detonation of 1,100,000 megaton hydrogen bombs. No wonder it reaches us. Powerful flares can significantly affect Earth, causing radiation storms in the upper atmosphere and disruptions in radio communication. Moderate flares sometimes lead to temporary disruptions in radio communication in polar regions and can cause mild radiation storms. But I'd like to touch on coronal mass ejections separately. It's a very interesting phenomenon. During solar flares, accumulated magnetic energy in active zones of the sun primarily transforms into electromagnetic radiation. During coronal mass ejections, this energy is used to accelerate material on the sun's surface. Like solar flares, coronal mass ejections increase the radiation level in the upper layers of Earth's atmosphere, affecting spacecraft and radio communication. A distinctive feature of coronal mass ejections is that they carry charged particles that interact with Earth's magnetic field. The effects of this interaction depend on various factors, including the volume, speed, and magnetic properties of these particles. Often, these effects manifest as magnetic storms and auroras, and I'll explain a bit more about that now. All protective layers are susceptible to influences, even those surrounding our planet. When the sun emits an especially intense stream of particles reaching Earth, they interact with its magnetic field, causing its vibrations and even tremors, which form the basis of a magnetic storm, also known as a geomagnetic storm. The strength of such an impact on Earth's magnetosphere is related to the level of solar activity following an 11-year cycle. 4 years of increasing activity and strengthening solar wind, followed by 7 years of gradual calm. During peak activity periods, the sun demonstrates more frequent and powerful flares and mass ejections, which occur rarely, about twice a century. The first recorded solar flare on September 1, 1859, caused one of the most powerful geomagnetic storms known, leading to significant disruptions in telegraph communication and auroras visible even in tropical latitudes. Currently, We've reached the peak of the current cycle, which is why we've been hearing so much about the strongest magnetic storms in recent months. Alright, we've covered storms, but what about the northern lights? Where does this breathtaking beauty come from? Although we don't feel the fluctuations of Earth's magnetic field, we can witness an impressive optical phenomenon associated with magnetic storms, the northern lights. Isn't it mesmerizing? This glow appears in polar regions, when cosmic particles moving along the magnetic field lines of Earth that nearly vertically enter the atmosphere at these latitudes reach the lower layers of the atmosphere, seemingly sliding down them. This insanely beautiful phenomenon occurs thanks to charged particles penetrating Earth's atmosphere in polar regions and interacting with gases like nitrogen and oxygen. When particles collide, they transfer energy to atoms, which then return to their normal state, emitting photons, particles of light. This process creates bright bands, columns, and loops in the sky, coloring it depending on the absorbed energy in green, brownish red, red, or blue hues. My personal experience of observing the northern lights tells me that in person, it seems even brighter and more impressive than in photos or videos. So I'm absolutely sure that at least once in a lifetime, you have to see it with your own eyes. With the increasing dependence on modern technologies and electrical grids, vulnerability to magnetic storms also increases. Why? The expanding use of satellites and sensitive electronics, as well as the lengthening of power transmission lines, worsen the potential damage from magnetic disturbances. In them, alternating current creates a magnetic field around it, affecting ions in the air, creating so-called parasitic currents. Usually, they don't pose a significant problem, but during magnetic storms, their activity can significantly increase, threatening overheating and damage to equipment. Relay protection systems are designed to prevent such failures, but they themselves may be vulnerable during magnetic storms. To minimize the risk of false triggering of relay protection, systems are used to convert alternating current into direct current, preventing the formation of parasitic currents. Additional protection measures such as lightning rods contribute to redirecting electric charges to the ground, especially relevant in the Arctic, where other conditions may affect the effectiveness of such systems. Despite the potential threat from magnetic storms, existing protection measures reliably safeguard electrical equipment even in the northernmost regions. Magnetic storms not only pose a threat, but also represent a potential source of energy, especially for remote areas where fuel delivery is challenging. The electric current generated in conducting circuits during magnetic storms can be converted and used to charge batteries. This opens up prospects for using magnetic storm energy as an alternative power source in hard-to-reach regions, although currently, it remains a costly and technically complex solution, requiring further research and development. But if there's free energy, why not make use of it? But how do solar activity and magnetic fields affect living beings? Science confirms that Earth's magnetic field has a direct impact on living organisms, which not only react to electromagnetic fields but can also generate them independently. Research in biophysics and medicine shows the beneficial influence of the magnetic field on the circulatory system, improving the condition of blood vessels, facilitating oxygen transport, and delivering nutrients throughout the body. But in the case of solar storms, the work of magnetic fields is disrupted, leading to discomfort for many people. Alexander Chizhevsky, an eminent Russian biophysicist based on extensive statistical data, proposed a theory about the significant influence of geomagnetic storms on human health, linking them to outbreaks of various epidemics, including plague, cholera, diphtheria, influenza, meningitis, and relapsing fever. Research conducted at the Yerevan Medical Institute confirmed the impact of magnetic field disturbances on the incidence of myocardial infarction. It was found that during magnetic storms and in the following 2 days, the number of patient visits for cardiovascular problems sharply increased, as did the number of fatal outcomes. Typically, the body's reaction to changes in Earth's magnetic field occurs with a delay of about 1 day after the onset of a magnetic storm. It was also established that geomagnetic activity affects the circulatory system. Even during moderate storms, blood clotting increases by 2.5 times, and the sedimentation rate of red blood cells accelerates, increasing the risk of thrombus formation. The impact of the magnetic field on humans is unique and differs from other types of influences, such as chemical, thermal, radiation, or electrical. While the muscular and circulatory systems can, to a certain extent, protect the body from unwanted electric currents, and radiation can be partially absorbed by the outer layers of the body, the magnetic field penetrates and affects the entire body as a whole. Researchers from the Institute of Earth Magnetism, Ionosphere, and Radio Wave Propagation of the Russian Academy of Sciences believe that magnetic fields influence the body in the ultra-low frequency range, corresponding to the main physiological rhythms of the body, including heart rate, brain activity, and breathing. Notably, the frequencies of the so-called Schumann resonance, amplifying electromagnetic noise in the atmosphere, coincide with the frequencies of brain activity. Unlike other influences, the magnetic field may not be directly felt by humans, but their body nevertheless reacts to such an influence. This manifests in functional changes in the nervous and cardiovascular systems, as well as alterations in brain activity. But remember when I talked about the influence of solar activity on the human psyche? Psychiatrists have identified a correlation between the strengthening of Earth's magnetic field and the exacerbation of mental disorders, sometimes leading to suicidal actions. Kelly Posner, an outstanding psychiatrist from Columbia University in the USA, suggests that the disruption of circadian rhythms, natural cycles of biological activity lasting approximately 20 to 28 hours, and disruptions in melatonin production can be the case of the close connection between geomagnetic storms and psychological disorders. Melatonin is a hormone produced by the pineal gland, or epiphysis, playing a key role in regulating daily rhythms. Geomagnetic storms, influencing internal biological clocks, can cause destructive changes, contributing to the development of depression and increasing the risk of suicidal behavior. British researchers have also noted the connection between geomagnetic activity and neuropsychiatric disorders, confirming this regularity in studies involving around 40,000 patients. Petr Vasilik, a doctor of biological sciences, found that during periods of Earth's magnetic field strengthening, human growth slows down. Today, as the planet's magnetic field weakens, Vasilik associates this fact with acceleration, the accelerated growth and development of modern humans. Japanese scientist and physician Kiyoshi Nakagawa also expresses the opinion that the weakening of geomagnetic activity could be the cause of various ailments, including sleep problems, appetite issues, decreased immunity, susceptibility to diseases, joint problems, skin, urinary system, nervousness, and general fatigue. He called this phenomenon magnetic field deficiency syndrome. Additionally, a magnetic field deficiency can occur artificially in conditions where a person is in an isolated environment, such as a spacecraft or submarine, where the magnetic field is shielded. In such situations, people have been observed to experience significant disruptions in the body's functioning, including a decrease in metabolism and a reduction in the number of leukocytes, which can lead to the appearance of symptoms of various diseases. And of course, I must tell you about a very interesting science, geobiology. In his youth, at the age of 17, Alexander Chizhevsky made an unexpected discovery when Europe was experiencing the First World War, and his father, a colonel in the artillery, was involved in combat. The young man tracked the course of the war on the map, simultaneously being fascinated by astronomy and recording changes in the celestial sphere. To his surprise, he discovered a connection between the increase in the number of sunspots and the intensification of hostilities on Earth, allowing him to hypothesize about the sun's influence on terrestrial processes. After in-depth study of statistical, accurate, and historical sciences, Chizhevsky found that solar activity, changing in an 11-year cycle, coincides with major historical events. This confirmed his theory that the sun influences not only natural processes, but also human history. Later, in his home laboratory, he continued studying the impact of solar activity on microorganisms and found that bacteria causing diphtheria changed color before solar flares, further confirming his theory. Today, Chizhevsky's ideas about the influence of the sun on all living things have gained wide recognition, especially in the context of the observed increase in morbidity and accidents during magnetic storms caused by solar activity. This affirms the deep connection between solar activity and the health, behavior, and historical development of humanity. According to NASA's research, In 5 billion years, the life cycle of the Sun will come to an end, and it will turn into a red giant, ceasing to emit heat through nuclear fusion. This change will lead to the expansion of the outer layers of the Sun, which will engulf the closest planets, including Mercury and Venus, and have an impact on Earth, destroying its magnetic field and atmosphere. Scientists also speculate that a billion years before this event, a 10% increase in solar activity will lead to the evaporation of Earth's oceans, rendering our planet uninhabitable. Meredith Joyce from the Australian National University also claims that as the Sun approaches the end of its life cycle, it will significantly increase in size and potentially engulf Venus, Mercury, and possibly Earth, after which it will collapse into a white dwarf. Observations using the Hubble telescope have allowed astronomers to study the future of the planetary system, analyzing white dwarfs and detecting elements in the dusty disks surrounding some of them, which make up a significant part of Earth's mass. This indicates the possible future of our planet on a cosmic time scale. The Sun not only illuminates and warms all living things, but also significantly influences our lives through magnetic fields and radiation. That's why thousands of people worldwide actively monitor it, and in the news, we hear warnings about increased solar activity. Thanks for watching.